All right, so yesterday I taught you how to write orbital diagrams, and you realize, wow, that's really kind of long. And you realize, there has to be a shorter one. Shorter way, and there is. The shorter way of doing these things is called electron configuration. Electron configuration. And basically what we do is whoa, what happened? Let's see. Okay. Basically what we do is we shorten it significantly. Where hydrogen, we would have to draw one box with an arrow up. Here, we just say, that's just 1s1. No, it has to be 1s1. So you have one electron in the s of the first floor. Helium would be 2 electrons, right? Its atomic number is 2. It would be 1s2. That finishes the first floor. Then we begin again, this time with lithium. Lithium is going to have what helium has, but we need to place 3 electrons because lithium is number 3. So 1s2, Maddie, what would be next? No, we've already used up the first floor. First floor is done. First floor sauna, full. What would go next? 2s1. Freddie, follow the pattern. Beryllium, 4. Now, keep in mind that does fill up the second S room. Canaan, continue the pattern. Boron with number 5. Nope, because you can only have 2 electrons per room, and there's only 1 S room. 2s2. 2, no, you are done with the first floor with sauna. The first floor finishes it up with sauna. That's right. Yeah. Joey, continue the pattern with carbon.
There's 2 and 1 S. One in the first 2p.
Okay, that's the really cool thing about orbital diagrams. I mean, electron configuration, we can just summarize it. 2p2. And they do. And you can see that clearly in orbital diagrams. Right, you can't. You can't see Hund's rule in this way. That's why I'm telling you, I'm going to teach you this shortcut to orbital diagram, and then I'm going to teach you the shortcut to the shortcut, and then there's even a shortcut to the shortcut to the shortcut to orbital diagram. Every way is good at teaching a part of the story, but not the whole story. Orbital diagram helps us predict magnetism, but it's long. This way is shorter, but it doesn't explain magnetism. All right, so to you, Christiane, nitrogen, number 7. Follow the pattern. Okay, say 1s2. That is the proper way of saying it. 1s2, 2s2, 2p3. Malachi, follow the pattern. That was nitrogen. Malachi, oxygen has 8. 2p4. Zach, follow the pattern. You've got 8. No, because you have a potential for 6 people living in the P section. Remember? 3 rooms, 2 people each, 6. Zach, follow the pattern. Robert, follow the pattern. Danielle, follow the pattern. What? You can't have 7 in the P section because 6 is the maximum. So the first floor is done, the second floor is done, you go up to the third, and what's the first type of room you always encounter? And how many students need to live there? Okay, now I could continue, but guess what? It would follow the same pattern as the one on the left. For example, magnesium would be just like this one, only, so you draw all the stuff before, then you go 3s2. Then the next one would be all the stuff plus 3s2, 3p1. All the stuff, 3s2, 3p2. All the stuff, 3s2, 3p3. So it follows the same pattern over and over again. Yes?
So at the beginning of this, you said we're not supposed to get anything.
No, that was just that first lecture. No, this should be making sense because this is just pattern recognition. Okay. So let's do a couple of harder ones. Let's do lead. Lead is right here. Oops. Because once these things get big enough, they get a little confusing. Okay? Who would like to try this one with me? I'll help you. I'll help you. Of course, you have to use your periodic tables. All right, Freddie. So let's put numbers here. 1, 2, 3, 4, 5, 6, 7. Let's also put down S, T, D, and F. Okay, so we need to, we're right here. That means everything else needs to be filled in. So we begin, by the way, helium should be there. The reason why they tear helium out and place it on the other side is because, like the others, noble gases, helium is a noble gas. It kind of symbolizes a complete floor. So that's why helium is over here. Sometimes you'll see hydrogen over here. Hydrogen and helium. Okay? Don't let that confuse you. Go, Freddie. Lead, 82. Go. From the beginning. Go. Okay, so he just described these two boxes. Understand? How about these? Okay, so now empty, 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 and these. These. Empty, 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 empty. This one. 3p6. That one. No, we're in the fourth floor, S section, 4s2. Now, things get weird because remember me telling you about this. In order to get to the D section, because of the difference in height, elevation, you have to go to the fourth floor, you see the S room, and then you go and see the sky bridge leading up to the D section. So now we've gone into the fourth floor where you will find the sky bridge for the 3D. The D's are always one floor behind. So why don't you do that? Why don't you say here next to the D, one floor behind. So if you're in the 4th floor, ready, that becomes what? It's in the D section. You got to say it in the correct order. Floor, type of room, total number of students. Okay, can't be 4D because the D section is 1 floor behind. So if you're in the 4th floor, you are really in the 3D section. 3D10. Now the P section is the same floor. Go. Okay. At this point, things get a little hairy. You need to take your writing utensil and draw this separation between the 6S and the 7S and the D section. Draw it nice and thickly between the two. Okay, you went too far there, Freddie. It's between barium and radium and the D section. And then I need you to draw arrows from that thick wall down to here to remind you that once you get to 6S2, what comes after 6S2? The F section. And the F section is always 2 floors behind. So if you're in the 6th floor, the F section is 4F. If you're in the 7th floor, the F section is 5F. I'll explain it here in a second. I know. 6S2. Freddie, what comes next? $14. After that, you come back here. Six P2. Elaine, are you paying attention? This is, I see you're not writing anything, which is very interesting. Okay? Don't mind your little designs, but this is important. Okay, did you see that? It's kind of confusing. Now, Kanan, you're right. Over here, it gets really confusing. This whole section is the next one. You see, what they do is they pull the LA and the AC down here. The best thing to do is to do what I told you to do, and that is once you get to that wall, just come straight down. Once you get to the wall, straight down. All right? Wow. Let's erase this and try CR. That's a whole lot easier. Kanan, you want to try it?
Yes.
All right, go. No, I know where it is. You need to tell me the electron configuration. There are 2 electrons in that S room. You blew right past chromium, which is bad. Chromium is the fourth element in there. So it'd be 3D. What do you think?
Yes.
Let's do another one. Bromine, Ryan Register. Thank you for volunteering. Oh, sorry. Didn't mean to say your last name, Ryan Register. Okay, bromine is this one. 1s2. Well, you ignored this and you went straight to 2p6. This is 2p6, which means you're ignoring this right here. Okay, Christian, hush. I didn't hear you. I'm sorry. 2s what? 2s2. Next. Yes. That's not the p section. Not the same thing. Let's take out our fingers and count. Ready? 1. Don't worry. My honors chemistry class has had trouble counting to 10 today as well. All right. Sierra, since you seem to be working so hard there, you're doing uranium. Don't get much harder than this. It's right here. We begin, Sierra, with let's start in the beginning. Forget about it. We're a ways away from getting to uranium, so it's okay. Look up here. So we start with what? PB? Did you say PB? PB is lead. I'm talking about we're starting here. The pattern. Oh, you weren't here yesterday. No wonder you're confused. Oh, okay. So focus. All right, Emma, go. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, okay, 5p is over here. You totally ignored the whole middle section. The D section is 1 floor behind. 1 floor behind, not 2 floors. 4d10. Next. 5p6. Continuing on. Okay, things get hairy now. That's not the D section. Or F. How many are in there? Okay, we come back up to there. We've already used 4D10. We're in the 6th floor, so six P is over here. We need this section right here. We're in the, which section is that? SP, D, or F? What? Okay, and the D's are always one floor behind. So if you're in the 6th floor, which D are you in? 5D10. Good job. Now, continuing on. Good job. Good. The F's are not in the same floor as the rest. The F's are always, does it say there on your periodic table? Did you not write it down? The F's are 2 floors behind. So if you're in the 7th floor, which F are you in? Good. 5F what? Well, you just blew past your rating. 5F3. Emma, that was the hardest one. And with a few glitches, you did a really, really nice job. Really nice job. What do you got? What do you guys think? This is still kind of long. You've got to learn the pattern. You've got to learn the pattern. Yes? Okay. So, back when my kids were small and we couldn't afford to fly down to South Florida, which now that it's just me and my wife and maybe my son, we fly down to South Florida. We used to take that 16-hour drive down there. And I told you, you know, the way down there was kind of tough. The way back was a little easier because usually we were tired, we wanted to go home, and we knew that every mile got us 1 mile close. Everything's okay until we hit Georgia, the Georgia state line, and then we started seeing these terrible, horrible signs. During the summer months, terrible, horrible signs. Keep in mind that we were done with our vacation, which meant I was probably tapped out for money. Nevertheless, these signs enticed us to spend money. What were the signs during the summer? Only in Georgia, only in South Carolina. Peaches. Peaches. Get off this exit and buy fresh peaches. So, first couple of signs, my kids are asking, can we get off and get some peaches? I say, no, I'm out of money. Another sign goes off, can we get peaches? No, I'm out of money. By this time, I'm getting hungry and I'm beginning to think, oh, a peach would be just perfect right now. So, eventually, I give in. And we get off and I buy a box of peaches. So it doesn't take us very long before the kids are saying, can we eat a peach? No, let's wait till we get to the Tennessee line. Can we eat a peach? No. Okay, maybe just one. So we eat a peach until we start crunching into something hard. And that is the pit. Okay, so they asked me when they were little, what should we do with the pit? And I'm thinking, well, I mean, it's biological, isn't it? It's biodegradable. It's not going to hurt anything. Throw it out. So we used to throw it out the window. And then I read this article about how the Georgia lawn mowing people are constantly having to lawn mow over little baby peach trees. And then I realized, okay, yeah, it is biodegradable, but we're just planting trees up and down the I-75 corridor. Yes, and the article went on to talk about how many peach trees are found up and down I-75 every year. Why? Because, I mean, think about what Mother Nature wants to do. Mother Nature has these peach trees, and these peach trees are, you know, their job is to make more peach trees. So they create little babies, which are the pit. Okay? Now, they don't want the babies just to fall off and start growing right next to them because that's competition. So they want animals, mammals mainly, to pick up their kid and take them somewhere else. So what do? In order to entice us to get their kid and take it somewhere else, they build this fleshy, juicy, sweet covering all over it. We want the fruit part. They want us to eat the fruity part and to throw their baby away where the baby can grow. So I was just doing, me and my family were just doing what the peach tree wanted us to do. All right. I didn't know that it was being a big bother to the Georgia highway cleanup crew. All right. All that to say, the fruit is what's important to us. The pit is not important, so we throw it away. In the same way, most of the electrons, and we drew quite a bit here, most of these electrons are absolutely useless to us. We don't need them. They're not important. They're like the pit. We can't throw them away, but it would be really nice if we could somehow summarize them, and we do. When we do condensed electron configuration, what we do is we include the noble gas that's inside. Because what's so special about noble gases? They're at the end of the periodic table, and they complete the sequence. They complete the sequence. They complete the floor. So what we do is we find the noble gas that's inside, and we put it in brackets, and we continue from there. Let me show you how much fun this is. Because 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6 is xenon. Xenon. So we're allowed to erase all of this and put down xenon. So the answer is xenon 7s2 5f3. That is the condensed electron configuration. You find the noble gas that's inside, and then you write the condensed, then you write that noble gas in brackets, and then you continue from there.
I feel like that's kind of
Not really, because those electrons really aren't that important. Okay, so let's practice some of these before we leave. Lead is right here, I think. Yeah. So what you want to do, lead is number 82. What is the noble gas that is closest to number 82, but not beyond it? Xenon. So you put down xenon. Xenon is right here, and then you continue from there. 6s2 4F14, 5D10, 6P2. And that's a whole lot quicker than the other one. I will tell you what I want you to use, whether it's complete or condensed or whatever. How about chromium? Chromium is right here. Chromium is number 24. Which is the noble gas that's closest to chromium? Okay, so you put down for chromium, you put down argon, which is right here, and then you continue there. 4s2, 3d4. Okay, let's stop right there. And all right, so we've looked at the really, really long way to do this, which is orbital diagrams. That's when drawing the little boxes and the arrows. Oh my gosh, please don't ever ask me to do a really big one on those. We've looked at electron configuration, which is definitely shorter than orbital diagrams, but still, they can take a long time. We have now done condensed electron configuration using the kernel, what I call the kernel, the seed. Okay, so now let's do a shortcut to the shortcut to the shortcut to orbital diagrams. Okay, how do you determine the number of outer shell electrons? Well, what is the outer shell? The outer shell is the SN or P electrons, the S or P electrons that are beyond the noble gas, the condensed, the kernel. Okay, so they're the ones who are past the kernel, past the kernel. They also end up being the group number that the element can be found in. And I'll explain that here in a second. You're gonna love this. This is so easy. Typically, I'm dead on. Yeah. If it's hard, I say it's hard. If it's easy, I say it's easy. Why are they so important? Because they're the farthest away from the nucleus. So they're the ones that are most likely to be lost, or they're the most likely for you to add on to them. All right, so let's find the outer shell electrons for calcium, tin, radon, aluminum, fluorine, potassium, molybdenum, platinum, and thorium. And what we need is a periodic table, and we need somebody to please remind me what all these things are. Okay, so calcium, I believe, is found right here. I know, I haven't done anything yet. Calcium is right there, right? Okay, so calcium's electron configuration, I just want to show you this, see how it works. Calcium's electron configuration will be, what is this noble gas? Argon 4s2. Argon 4s2. So, how many S or S and P electrons do you have? 2. 2. That's it. So, if you think about it, there are only 8 columns. First, second, third, fourth, fifth, sixth, seventh, and eighth. So if you find your element, Robert, in the second column, they're all going to end up their electron configuration with an S2, just like calcium. Therefore, they will all have 2 outer shell electrons. So if you find anyone in the second column, magnesium, beryllium, strontium, barium, radium, they will all have the same outer shell electrons, 2. 2. All right. Tin should be right here. Okay, so let's get a volunteer. Reagan, thank you for volunteering. Who is this noble gas that's inside? Krypton. Then continuing from there, what's that? 2s2 is way up here. 5s2. Yes, 4d what? 4d10, and then we go a little bit further. Okay, all we care about are S and P electrons. So how many S and P electrons does tin have? Folks, do you see that if you are lead, beneath you're still going to have the same outer shell? If you are above tin, germanium, you're still going to have the same outer shell. Everybody that's in this entire column will have the same outer shell. And that outer shell is 2 in the S, 2 in the P. 2 in the S, 2 in the P, for a total of 4. So just by looking on the periodic table, we know that everybody in that row has 2, and we know that everybody in this row has 4. Radon is over here. Malachi, thank you. So who is the noble gas above it? Radon is number 86. Malachi. What? Oh, xenon. All right, xenon. So we're right here, so we need to now start right there. Which floor, says Bud? It's not up here. It's probably on your periodic table, though. Try again. 6. Which section is this? S. Okay, so we blow right past S. So how many are we talking about? How many are right here? 2. All right, there should be a blank wall right here with arrows facing down, which tells you you need to go down to this section. What is that section? Which F? Which floor is it on? Remembering that the F floor is always 2 floors behind. 4F what? How many are in there? Should be 14. All right, Malachi, we need to come back right there. What section is that? Which floor? No, the D section is always 1 floor behind. 5D what? If it's completely full. Nope. Let's work on that together. Malachi, look up here. Ready? 1. Count. So it's not 14 or 15. You were a little off. What is it? 5D10. Okay, we're now in the right section, and we got to go all the way to the end. Need help counting again? What section is this? Okay, which floor? We've already used up the 5 over here. That's 5. The S and the P are always in the same floor. 6, P what? Let's count together. You ready? Six P6. All right, since we don't care about D's and we don't care about F's, how many S and P electrons do we have here, Malachi? Since we don't care about F's and we don't care about D's. 8. What you're going to find is if you do the condensed electron configuration for all of these, they will always end up the same way. 5s2, 5p6. 4s2, 4p6. 3s2, 3p6. In other words, every element, with the exception of helium, every element on this last column will have how many? So what makes this so easy? All you do is you look on the periodic table. If you find anybody in that column, the answer is 2. Anybody in this column, the answer is 4. Anybody in the last column, the answer is 8. Yes, Christian. We're getting there. What's the next one? What? Aluminum should be right here. All right, AC, give me the electron configuration, the condensed electron configuration for aluminum. Neon, go. 3s2, 3p1. How many S or P electrons do you have? 2 plus 1 is 3. Can you see it doesn't matter whether you're boron, gallium, indium, or thallium? The noble gas is going to change. The floor will be the same, but it's still going to be S2P1, 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 which means everyone on that row, that column, will have how many outer shell electrons? 3. So now we've got this one, this one, this one, and this one. Fluoride. All right, Emma, do the condensed electron configuration for fluorine. And how many S and P electrons do you have? 2 plus 5 is 7. Same thing here, gang. Fluorine, S2P5. Bromine, S2P5. Iodine, S2P5. Acetone, S2P5. So what have we discovered? Everyone in that column will have how many outer shell electrons? So if you're in this column, you have how many? If you're in this column, how many do you have? All right. Do you see the pattern? Okay, what's the next one? Potassium is over here. Do you see the pattern? How many outer shell electrons? Patience. Next. MO. Molybdenum is over here. Okay. Kanan, you want to do this one?
Yes.
What is this noble gas right here?
That is
Krypton. Continue on then. All right. How many S or S or P electrons will you have? But what about the D section? You don't care about D section. But Mr. Brand, no, you don't care about, what about the F section? You don't care about the F section. So how many outer shell electrons will everyone in this row have? And this row? And this row? And this row, 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 and over here, and over here, and over here, and over here, and over here. So if you fall inside of the D or F section, automatically all you have in your outer shell is the S2. So you have just 2 electrons. Next. What? PT is down here. You think it's 2? You would be correct. What's next? Thorium is down here. You would go with 2? Correct. What else? That's it? What about phosphorus? What about sulfur? All right, gang. So do you see why it's so much easier to do it this way? Okay. So everyone wants to be like a noble gas. Everyone wants to have 8. 8 is great. So if you fall in this column, what do you want to do in life? What's your goal in life? Gain how many? 1. Because you have 7 and you want to have 8. If you fall in this column, what's your goal? Gain 2. Why? How many do you have? 6. How many do you want? 8. If you fall in this column, what do you want to do? You have how many? You need how many? How about this column? You could gain 6, or if you lose 2, then you become like the noble gas that's inside. And that is why we have these charges. Okay, so let's stop right there and let's practice.